Hello everyone, and welcome to the wonderful world of Web APIs with ASP.NET Core. My name is Daniel Roth, and I'm a Senior Program Manager on the ASP.NET team. And in this presentation, we're going to talk about using ASP.NET Core to build rich and powerful and even secure Web APIs. Here's a brief outline of what we're going to talk about today. I'm going to give you sort of an overview of what we are trying to do with Web APIs in ASP.NET Core, building a single aligned framework for building both Web UI and Web APIs. I'll show you how you can get started with ASP.NET Core, and then I'll walk you through a whole bunch of the really cool Web API features that we have in the framework, including things like routing and formatting. I'll show you how you can set up metadata for your Web APIs using Swagger, and even test your Web APIs using a built-in browser test client from the Swagger folks. And then lastly, I'll show you how you can secure your Web APIs using your organizational accounts. So ASP.NET Core is a brand new web framework, open source, cross-platform, cloud optimized, built on top of .NET. And one of the things we wanted to do with ASP.NET Core was give you a consistent and unified experience for building both Web UI and Web APIs. In ASP.NET today, we have a variety of frameworks that you can use to build web applications and web services. There's ASP.NET Web Pages, there's ASP.NET MVC, and Web API. And each of these frameworks works great for what they were built for, but there's a lack of alignment and consistency between them. For example, Web Pages and MVC, they both use Razor as their view syntax, but that's where the sharing stops. They both have their own, for example, HTML helper implementations. Between MVC and Web API, they look actually pretty similar. They both share a bunch of concepts like controllers, actions, filters, dependency injection, model binding, but they actually share no code at all. And this is for historic reasons. MVC was tied to IIS. We wanted Web API to be able to be self-hosted. But this causes two problems. One, it's twice the work for us. When we ever want to implement a feature for MVC or Web API, we often end up implementing it twice. And it's bad for you because it means that you have two sets of features that you have to pick between, which causes confusion. So how can we fix this? Well, in ASP.NET Core, we are aligning MVC, Web API, Web Pages into a single aligned web stack that can do both Web UI and Web APIs. It removes duplication, so you have one set of concepts to deal with. It's part of ASP.NET Core, so you get to take advantage of all the wonderful features in ASP.NET Core, like all the middleware, the hosting model, the dependency injection abstraction. It supports .NET Core, so you can run it cross-platform on Linux, on Mac, on Windows. It has no requirement to use IIS, so you can run it self-hosted in your own process. You can run it behind IIS. You can run it behind your web server of choice. And it has deep integration with ASP.NET Core features like the dependency injection stack. Specifically for Web API, there's a whole suite of really great features for building Web APIs using ASP.NET Core. We have built-in attribute routing to make it really easy to get requests to your action methods. There's built-in support for model binding data from the requests to your action methods and also validating that data. We have built-in support for link generation, formatting. I mean, web services are all about formats, whether it's JSON, XML, or whatever format you'd like. And we have great support for content negotiation, where clients can request specific formats for specific resources. You can generate metadata for your Web APIs using standardized formats like Swagger. And we have a wonderful security story for Web APIs as well. We have support for using bearer tokens like JOT tokens or JWT, JSON Web Tokens. There's also support for JSON Patch and for cores. And I'm going to try to show you as many of these features as I can in this presentation. I think I'll get to all of them except for the last two. So how can you get started with ASP.NET Core and building Web APIs with ASP.NET Core? Well, first thing, you're going to want to acquire .NET Core, and you can do that by going to .NET. And you'll want to install .NET Core for whatever platform you happen to be running on, whether that's Windows, Mac, or Linux. Our docs and tutorials can be found at docs.asp.net. And if you want to just see the code, you can find that at GitHub at github.com/asp.net. All right, so let's go ahead and get started with some demos. So I'm in Visual Studio right now. So I have already installed .NET Core. You can do that by clicking this Get ASP.NET button on the ASP.NET site, or like I said, you can just browse directly to .NET, and that'll take you to this site, which I will shrink a little bit so you can see it. And you'll want this middle option to install .NET Core. There it says this is how you can get started with ASP.NET Core. click on that, and you'll get installation instructions for your particular platform. I happen to be on Windows. If you're on Windows, you'll want to make sure you get the really awesome tooling for .NET Core and ASP.NET Core for Visual Studio. There's the installer right there. If you're on Mac, you'll get instructions for installing on Mac as well, and I highly recommend that you go and get the tooling for Visual Studio Code, including the C# extension. And that'll give you IntelliSense and debugging on a Mac for doing .NET Core development. Visual Studio will also give you some nice getting started points, some templates that you can use to build web apps, web APIs. If you're on a Mac, you can try out the ASP.NET Yeoman generators to give you exactly the same content as what we produce in Visual Studio for templates. I've already done that, so I have Visual Studio here. Let's go ahead and build our first web API with ASP.NET Core. I'm going to do File, New Project. And I've already selected the web node in the new project dialog, and you can see I have a number of options here. Here's the existing ASP.NET stack. That's if you're building applications that are targeting the full .NET framework, like using things like MVC5 or web forms. But here are the ASP.NET Core options. There's the first option is for running on .NET Core. That's so I can build an app that runs cross-platform, supports side-by-side versioning. I also have an option to build an ASP.NET Core app that is running on the full .NET framework. That will, of course, only run on Windows, but it'll give you full binary compatibility with existing .NET Framework binaries. I want the cross-platform goodness, so I'm going to pick the .NET Core option. I'm going to rename this to be my first web API, and that looks good. All right, so here are the various templates that we have available for ASP.NET Core, empty, a web API, or web application. I'm going to pick web API, and for now I'm going to start with no auth. We'll add security in later. Click OK. And this is going to create me a web API project using ASP.NET Core. Now, what do we got here? Well, first thing to notice is that this is just a .NET Core application. And I can see that because it's literally just a console app. ASP.NET Core apps are just console apps. And here's the program.cs file that defines my console application. What's in this code? Well, first of all, I've got my web host builder. That's what's going to wire up ASP.NET Core hosting. And once I've built my host, I then just run it to start listening for requests. When configuring the web host for my application, I can say things like, for example, what server do I want to use? In this case, I'm using Kestrel, which is our out-of-the-box cross-platform managed server, HTTP server for handling HTTP requests. You can specify your content root. That's the directory where you want your application to find things like your MVC views. IIS integration, this particular app, because I'm running in Visual Studio, it is a console app, but it's actually going to run behind IIS. So, and the way that works, you can see it in the web.config file for this template, is that there is a native module. We call it the ASP.NET Core native module that runs in IIS. And as requests come in, the only job of that module is to hand off those requests to a process of your choice, which would be your console application, your actual app. So that's what I'm doing here. So since I'm in Visual Studio, I'm actually running with IIS Express using this native module that's just going to hand off requests to my application. So that's this line is just enabling integration with IIS. And then lastly, use startup to define the actual application logic for your app. You use a startup class. And this line is saying which startup class I want to use for defining my app. All right, cool. So let's go look at that startup class and see what this app is actually doing. So here's the startup class, and there's really three things that are happening in this startup class. There's the constructor and then these two methods. So if we look at the constructor, all the constructor is doing is setting up configuration. In ASP.NET Core, we have a new lightweight configuration model that gives you a really easy way to get name-value pairs. Oh, I'm probably seeing some feedback. My font's a little small. Let me up it a bit. There you go. Hopefully that makes it better. The configuration model is a really simple way to get name-value pairs out of a variety of configuration sources. For example, JSON files, XML files, INI files, environment variables. In this particular app, it's reading configuration values from JSON and also from environment variables. And because you can configure multiple providers, they can actually override each other. So for example, maybe during development, I want to use some specific config values just during development. But then when I publish into production, maybe I want to override like my connection string with the actual production connection string. And I can do that with an environment variable. So that's kind of nice. It has that ordering and that override semantic. Okay, so constructor is just setting up config. This first method, configure services, what is that? Well, this is setting up all of the services that I want to be made available to my app via dependency injection. ASP.NET Core has a first-class abstraction for DI, for dependency injection, and all of our frameworks leverage it. And you can too. You can plug your own services into the DI abstraction. We have a really simple DI container that we ship by default, but you can also plug in whatever container that you'd like AutoFac or Ninject or what have you. So here you can see MVC is adding its services to the service collection and making them available to everyone. And then this configure method, well, this is where you actually set up the HTTP request handling pipeline for your application. This is where a request comes in. This is the code that's actually going to run to handle that request. This is usually you set up a set of components that we call middleware in that pipeline that will either look at the request and pass it along, or they can respond right away, or it can throw an error, whatever you want to do. That's where you actually are defining your application logic. You can see in this configure method, there's just a little bit of code to wire up some logging. That's useful for debugging. And then I'm using MVC middleware. The MVC is actually built on top of generic routing middleware. And it just sets up MVC as the route handler for that route middleware. So it's just one single piece of middleware that's sitting in this app. OK, great. So I'm using MVC. So for my web API, then I expect to see something like a controller for my API. Do I have that? Yes. So let's go look in the Solution Explorer under the controllers folder. There's a values controller. Cool. So this guy derives from controller. There's some route information here. Let's just run this app and see what it does. So I'm hitting Control F5. This is going to fire up IIS Express. And I'll make this a little bigger too so you can see it. And you can see I got some values back. So this is values 1, values 2. It's a JSON array. That's just the result of this particular get action. It's returning a collection of just string values. But what about this URI? So it's API/values. Where did that come from? What determined what made this GET request from the browser arrive at that particular action on my controller? Well, that was done using attribute routing. So attribute routing is just you apply attributes to your controllers and actions to specify how requests should be routed to your actions. On this controller, I have a base route using the route attribute. And here is my attribute route. And you can see that requests that go to API/bracket controller should go to this controller. What is that bracket controller? That's a new feature in ASP.NET Core. We call them route tokens. Often with web APIs, you want your routes to map cleanly to your programming model. Like you often want the route to map to the controller name. And so before you could just type in API/values in this route, and that would work. But then if you refactored your controller name, like let's say I changed this to to-dos, right? Well, you'd have to go into the route beforehand and change it to to-dos. But because I'm using a route token, we will, when creating the route, we will add the correct route values to replace that token so that you get the route that you actually want. If I go back to my the browser, I'm still at API/values. If I hit this again, remember I changed it to to-dos controller, not values controller anymore. I expect to get a 404. Like that's no longer the URI for this resource. If I change it to API/to-dos, and now I got my data again. Okay, so that's route tokens in attribute routing. Let me change this back to values just so I don't forget. If I can type, there we go. I'll save that. Okay. Now you'll notice that there's also attribute routes on each of the actions. HTTP get, HTTP post, HTTP put. That's specifying the HTTP verb for each of the actions that they should respond to. And you have an opportunity to specify additional attribute route information right there. So for example, this let's go to the get action. This get action is taking an ID, and you can see it has an attribute route that's specifying curly brace ID. The way attribute routes on actions work is they are actually concatenated with whatever attribute routes you specified on the controller. So the full route for this get method is actually API/the controller name / the ID. Now the curly braces mean that this is a route parameter. This is a value that isn't being used to define the actual text of the route. This is a value that you actually want to extract from the URI when it comes in and matches this route. So I actually want to get the ID value out of the URI and make it available to my application. And the model binding system in ASP.NET Core will automatically map this ID parameter to the parameter of your action method just by name. So I should get this ID there. And we can see that if I go to, I'm no longer at to-dos. I want API/values/ let's say 123. I should expect it to go to that get method that just takes an ID. And there's just returning value right now. Let's actually use that data. We'll put in a little string interpolation in here. So ID, there we go. Now we should actually, we should see that ID in the value that gets returned. And by the way, I'm just editing the file, saving and refreshing. That's a nice feature of ASP.NET Core, is that we'll detect file changes, kill the process and restart it again, so you don't have to keep rebuilding and refreshing. And there, that worked. All right, now an interesting thing is, what would happen if I typed, ABC here for for that ID pass segment? Well, if we look at the action method is binding the ID to an int. Well, ABC is not an int. So model binding will detect that those things should align, but it'll be like, well, the types don't match. It won't actually fail. It'll keep going, but you'll basically get a model validation error, and you'll just get a default value for that int. How can we fix that? What if I want to say I only want ints for the ID for this particular action method? Really simple. There's in attribute routing in ASP.NET Core, we support inline constraints. So you're using this colon syntax. You can say this ID. This route should only match if the ID is actually an int. Okay, if it's not an int, then this route shouldn't even hit. Okay, so if we go back to the browser now, let's make sure it's still working for int values. So 1, 2, 3. Okay, good. And then if I type, ABC, now I get a 4, 4, because that doesn't match anymore. It doesn't meet the constraint of the route. So we have inline constraints also in ASP.NET Core Web API. All right, cool. What else do we want to do here? So this API, so we have post, put, delete, action methods on this template, but they're not really implemented with anything interesting. And so far, we've only been dealing with primitive types. Let's start adding some complex types and start dealing with some more interesting formatting. So I'm going to add a new type. I'm just going to put it in this file for simplicity. Let's public class value, and let's give ourselves some properties here. I don't know, an ID, string. Let's give it some text. All right, so now we got a value, and let's update our values controller now to, instead of just returning a bunch of strings, let's return some values. So a value array, instead of value 1, value 2, let's add some values in here. So new value 1 should be fine. And let's call this value 1. So there's one value. Let's add another one. Why not? Value ID equals 2, and then text value 2. That looks good. All right, cool. So that's all. Looks like it's all compiling. And then for my get action, it takes an ID. Let's, instead of returning a string, let's return a value. And here, let's say, yeah, let's do the same thing. Now, new value ID equals the ID. And then the text will just be, we can just leave this as value. The ID is already there, right? All right, good. Let's save that. Let's make sure that's actually working. So if we go back to our, 3, 2, 1 values, or getting a specific value with a specific ID, I should expect to get now a complex type. Yeah, okay, so I'm getting some JSON back, okay? So how's that working? There's a configured set of formatters in ASP.NET Core that are used to format any response data. By default, we only add JSON and also plain text if you return a string. But you can add other formatters as well, and we'll do that in just a moment. Okay, let's check the other one to make sure we're actually getting an array of values. Yeah, okay, good, we are. All right, now let's do post. I want to actually be able to create value resources on my server. I want to post a value. So let's implement post. So post, instead of taking a string, it's going to take a value now. Now, like I said, post usually, the semantic of post usually means create. So if it succeeds, and you're a good HTTP citizen, you should probably return a 201 created status code to tell the client that, yep, I got it, it was OK, and I actually created that resource. It's also nice to tell the client, where did you create that resource? And usually you do that by specifying a location header in the response. And it's just a URI to say, yeah, I created it, 201, and it's here. It's at this location. Okay? And we can create that location header using ASP.NET Core, using the built-in support for link generation. Because just as we can route requests to actions, we can also generate links to actions, sort of doing the inverse. So you can route, you take a URI and get it to an action, and you can take an action and get back the URI. So let's see how we can do that. Now there's a nice helper method on the controller base type that we can use. We're going to return a created at action result. All right? And this helper method will just help us create that action result in a really simple way. If we look at the overloads, so the first two parameters in this overload are basically the data that ASP.NET Core needs in order to generate the link, to generate the location header. It needs the action name and any route values that should be specified as if you were calling that action. So the action name where these values should be created, well, let's use this get action, right? That's how you get an individual value. So let's use that. So it'll be get will be my action name. And then for the route values, I need to specify an ID. And I use this anonymous object syntax. So ID equals, well, let's use the ID from the value that we got. There we go. And then it's also considered nice to return a representation of the resource that was just created. So I'm just going to return the value back to the client and say, yep, I created this value. Here's where it's at, 201. You're good to go. All right, so let's save that. Now this isn't compiling. See the squiggly, and that's because before this post action was returning void, I need to return an I action result. Cool. All right, now I should have post support on this web API. How can I test this? So I could break out Fiddler and send a post request. I could write a little bit of JavaScript or a little client. Instead, what I'm going to use is I'm going to use Swagger. So Swagger, like I said before, is a standardized metadata format for web APIs, and it also has a really nice browser-based test client that you can use to just try out your web API. So let's use that. Well, one thing I should make sure I call out is that notice that this post action is taking in a value. That's the value that you want to create as a resource on the server. And you notice it has this from body attribute. What does that mean? Well, that means that you want the request data to be bound to this value parameter in your action using the configured set of formatters. If you don't say from body, then by default, ASP.NET Core will just use model binding to bind form data. It's sort of by default handling form posts. If you want to handle like JSON or XML, using the set of configured formatters, then you want to mark that parameter as from body. Okay? So let's save that. Now let's, like I said, I want to test this method. Let's use Swagger to do that. Now there's a really nice third-party open source package that you can use for enabling Swagger for ASP.NET Core apps. So I'm gonna use that. It's called Swashbuckle. So we're gonna add some Swagger with Swashbuckle. Say that 3 times fast. So I'm gonna manage my NuGet packages. I'm gonna find Swashbuckle. There it is, and it's written by this wonderful gentleman, Richard Morris. So thank you, Richard, for your contribution to the .NET ecosystem. So we will install this guy. That looks good. All right, so this is installing my package, and really when I install this package, if you're not super familiar with the way .NET Core projects work, all it's actually doing is adding the package and its version to my project JSON file. That's the file that defines all the dependencies for my app, and it's the project file for my app. So you can see all the packages that my app is depending on here, and there you can see it just added Swashbuckle. And then it kicked off a package restore to actually pull down any packages that got changed or updated. And I can see those in VS. Like if I expand the references node, there's all the packages that my app is using. There's Swashbuckle. I can even drill down into the dependencies of each of those packages. And I love this feature, which is you can actually search through the Solution Explorer to see what stuff your app depends on and sort of where in the dependency chain it's being picked up. So there's Swashbuckle in my package graph. So that's kind of cool. All right, so we added Swagger. Now let's add it to our app. OK, so first thing I need to do is Swagger has some services that it needs to add to the service collection. So Swashbuckle, I should say, needs to add some services. So I'm going to add the Swagger Gen services. And these are actually built on top of a core service provided by ASP.NET Core MVC, which is our API Explorer service, which gives you sort of an in-memory representation of your API. So there's the add Swagger Gen services. And now I need to add some middleware to my app for actually specifying the endpoints for the Swagger metadata document and also for that little UI test page. So that's just middleware. So I use middleware in my configure method. So let's do Swagger Gen. That'll set up the actual metadata document endpoint. And then app.use Swagger UI. OK, and that'll add that UI test client. I'm going to save that. Let's go back to my app. OK, now I happen to know that the endpoint for the Swagger UI is set up by default at Swagger/UI. enter. And if it did everything correctly, then we should see a lovely little test client. And there it is. Sweet. Well, it's a little big. Make it a little smaller. There you go. Now, it's also telling me the address of where the actual Swagger document is at. If I opened up this guy, this is a big chunk of JSON. This is the actual metadata document that machines can process. They can use it for generating client code or for driving test clients like it's doing with the Swagger UI document. This will have all of the endpoints defined by your application, the schema for the resources, and so forth. And the Swagger UI app is giving me a visualization of that. If I expand values, I can now see my API in this test app. It's pretty cool. So I can see I can get the values, I can post the values, delete, get, and put individual values. All right. So if I go to the get option, I can see the schema of what I'm going to get. It's an array of these values. I can try it out. Let's get some JSON. And there it'll show me, the equivalent curl command script for making this call, what the request URI was, and there's the response. So that's awesome. 200 OK and all the response headers. Now I wanted to try out my post method, so let's do that. If I expand post, I get some really nice UI here. I can see that the post method is expecting a value, and I can see the schema for that value. There's its structure. If I click on this guy, it'll actually add that as a request that I want to try out. And let's do that. So try it out. And there's the curl equivalent, and you can see that it's sending an accept header saying that it would like the response back as JSON. And lo and behold, I get JSON back as the response. There's that 201 status code that the resource was created. And if I look in the response headers, I should see a location header. Yep, there it is. So there's the API/value/0. If I do a GET request to that URI, I would expect to get this resource. So that's pretty cool. OK, now I'm not getting any useful information about the response of this post action. Like I can see the actual response when I invoke it, but I'm not getting any metadata about it. And that's because if we look at that post action again, remember, let me go to the values controller. Yeah, I returned iAction result. So the API Explorer service in MVC, it doesn't know what that action result really is. What type is it? So it can't give any additional metadata about it. But we can give some hints to MVC to provide additional metadata, and we can do that using the produces attribute. Okay, produces. So this action produces a value. Okay, right? That's what it's going to return. That's what we specified here. All right. So if I save that and I go back to the Swagger UI, the little test client. Let's refresh. Let's see if we get something different. So now for post, for my response class, I'm getting the model schema for what this thing returns. And I can even see all of the formats that this particular resource supports. So, what are the configured set of formatters in my app? Right now, it's just JSON and plain text. But we can add additional ones. Let's go and do that. I'm going to add support for XML. So I have to add a package for that. This time, instead of using the NuGet package manager, I'm just going to do it directly in project.json. So I'm going to go into my project.json file, and we give you some nice IntelliSense here. Isn't that nice? So ASPNET Core looks good. MVC, I think it's formatters, and XML. That's what I want. That's the version I want. And when I save it, you'll see it kicks off a package restore. There's the package being added, and boom, there it is. Okay, so I've got my XML formatters now. I need to add them to my app. So I'm going to go back to startup. Let's see, there's MVC being added. I'm going to make sure I also add the XML. So there's two variants of the XML formatters. There's one for the data contract serializer, and there's one for the XML serializer. I'm going to use the data contract serializer one. Our JSON support is based off of JSON.NET. All right, cool. So now I should have XML. If I go back to my app, let's refresh. And let's see what we have for post. So if I look at post now, there's the schema for the response. And if I expand this, yeah, now I've got metadata saying this thing also supports providing representations as XML. So let's try it. So if I grab let's do another test request. Let's put some actual values in here. And I would like the response to be in XML. Try it out. There you go. So now the response body came back as XML. So that's pretty cool. So that's formatting, and we're getting content negotiation. The client said, I know you support multiple representations of this thing, but I would really like it as XML if you have it. And it gave it XML because we understand the content negotiation algorithm. All right, cool. Now, you can also restrict at an action level what formats a particular action is willing to serve up. Even though you've configured globally for your app that you support JSON, you support XML, you can also say, well, for this action, though, I really only support JSON, or I really only support XML. And you can do that, again, with that produces attribute. Let me go back to my values controller. So in produces, instead of just saying, this is the type that I'm returning, giving some response schema information, I'm going to say, this guy really only supports JSON for whatever reason. Like maybe it's fine that the get actions return JSON and XML, but for whatever reason, this post action only supports JSON. All right, and then type equals value. All right, that looks good. If I go back to the Swagger document, let's see how that changes things. All right, there's my post action. If I look at the response content types, now if I expand this, now I'm only seeing JSON. So it's kind of like a filter. With the produces attribute, you can say, even though I have these formatters configured, I'd like to filter that set to just these particular content types. I only want to support these content types for this action. So that's supported. You can do it on the other side as well. Like if you want to say, for requests, I only support these specific content types, you can do that. You use a different attribute, and it's the consumes attribute. So here I could say, I only consume application.json. And that works too. OK. Great. So that's all working fine. Last thing I want to do with this particular API is I want to add some model validation. Like often when you get a request, like a post request, you want to look at the data that you got from the client, check it out, make sure it meets your validation rules. And if it doesn't, you typically want to tell the client that 400 bad request. Bad client, you did something wrong, and usually you want to tell them what they did wrong. Like you forgot to send me this value and it was required, or this value is not within the right range parameters, stuff like that. So in ASPNET Core, we have built-in support for model validation, and you can easily serialize model validation errors back to the client. Let me show you how you do that. So first of all, let me go to my value model, and I'm going to add some validation logic to this model. Let's just make the text property required. There, I'm adding a data annotation to my model and saying that this text property is now required. And now if I go to my post action, all of the any validation errors that are found while validating the request, they all get stored in the model state. Yeah, so we should check the model state to see if it's valid. So if model state, and this is just a property on the base controller type, is valid. That's how you do that. This is basically saying whether or not there was any validation errors. In this case, I'm going to check to see if it's not valid. Was there a problem? If there was a problem, then instead of returning a 201, I now want to return 400 bad requests. So I'm going to use this bad request helper method, which will return a bad request action result. And this has an overload, which lets me pass in the model state. And when I do that, it will actually take the model state and serialize out the validation errors so that the client can see them. All right, cool. So let's try that. Does that work? Let's refresh. Did I save? Yes. OK, good. All right. So we go to our post action. Let's send a request. Let's just make sure that's still working. So I'm going to try it out. Do I get a 201? Yep, I got 201. That all looks good. OK, now let's send a bad request. We're going to take out the text property, which is a required property, so it needs to be there. Try it out again. And now instead of getting a 201, I'm getting a 400. And you can see the response body, instead of giving me some random value, it's saying, hey, this text property is required. You need it. OK, so that's how you do validation and actually serialize the validation errors back to your clients. Cool. All right. So that's great. So now the next thing I want to do is let's start trying to make this web API secure. We want to have a secure web API. So to do that, I'm going to actually work from the web API back to the wire. So the first thing, if you want to secure your web API, you typically need to have some filter, something that's going to prevent requests from actually making it to your critical business logic based off of your authorization rules and policy. And ASP.NET Core actually has a really powerful authorization system. you'll typically on the request you establish some sort of principal for the requester, for the user, which has a bunch of claims in it, and then you can run a bunch of authorization logic over those claims to decide, yep, the request is good, or no, this request is no good. 401, unauthorized. The most simple of those policies would just be, there has to be some sort of principle, and you need to be logged in. You need to be a user in my organization to actually call this API. And the way you can just really easily express that is just by applying the authorize attribute to your controller. So that will tell the authorization filter that this API should only be called if there's an actual real claims principle on the thread. Okay, great. So now I have a secure web API, right? But of course, no one can currently call it. How do we actually now send requests to this API that will establish a good principle and pass this authorization logic? Well, with web APIs, the typical pattern that you do is you use a protocol like OAuth 2, and you use bearer tokens that can be validated by the application to make sure that they're from an authority that you trust, that they're meant for you, that they're appropriately signed, and then if that token's good, then you take that token, that security token, and turn it into a claims principle. And how you acquire that token is usually done with one of the OAuth 2 flows. There are a variety of flows depending on what kind of client application you are. If you're like a server-to-server app, there's one flow. If you're a JavaScript app, there's another flow. But basically, there's a way to go get a token, a security token, an access token, from an authority that you trust. And that authority is usually called an authorization server. All right, so we need then some logic in our app that will look for these tokens, these bearer tokens, and will validate them. So the OAuth 2 spec defines a standard way for sending these tokens, the OAuth 2 bearer spec. And what it says is that you can pass bearer tokens using the authorization header and the authentication scheme bearer. You just say bearer, and then you put the token there, and that's how you can find the token. Now in ASP.NET Core, we provide you middleware that knows how to look for bearer tokens in the request, and it knows how to validate them. Specifically, it knows how to validate JOT bearer tokens, or JSON Web Token, I think is what that acronym expands to, which is a standardized format for representing a bunch of claims in a token. So let's use that middleware for establishing the principle on the thread, so people can actually call our web API. So let's first get the middleware. So I'm going to use the NuGet package manager again to get it. So it's JOT bearer, it's the one we want. There it is. Let's install it. Yep, accept it. And there's the package being added, it's being restored, and boop, there. Okay, we're good. All right, so now it's middleware, so of course I configure it in the configure method in my startup class. That's where all of my HTTP request handling logic lives. And of course, this is kind of like authentication, so you want it to happen really early in the request handling pipeline, like right at the top. Like each of these app.use statements are ordered, so you want to make sure the order matters. Make sure you put them in the right order. So I'm going to say app.use bearer authentication. Now normally when you set this up, inside here you'll have a bunch of options. Like this is where you'll actually configure, what authority do you want to use, and how do they get their signing, how do we validate their certificate, and what's the audience for this token, those types of things. So what token source should we actually use? What authority should we use for this app? Well, at this point you have a choice. I mean, it really depends what type of application you're trying to write and who your users are, what clients you actually need to support. If you're in a company, like in an organization, a company or a school, probably they have some sort of authority that's associated with that organization, some sort of directory. If you have an organization that uses, for example, Office 365, they have an Azure Active Directory authority that you can use to get tokens to call apps that have been registered with that authority. If you care more about a consumer-facing application where you have users just out in the world, there's also a service in Azure called the Azure Active Directory Business to Consumer service that you can use for client apps to get tokens that can then call your web API. There's also a variety of nice third-party options out there. There's some folks in the community, like the Identity Server guys that built Identity Server 4. It's actually built on top of ASP.NET Core, and it provides a token server solution, an identity server solution for applications if you want to deploy your own thing on-premise and manage it yourself. Now, managing a token server is a security-critical piece of code, so make that choice wisely. For this demo, I'm going to use one of our services because that means I can rely on Azure to do things securely, be hardened, use fancy AI to detect when things are going wrong, and it just makes my app that much simpler. Okay, so great. So I want to configure this Jot Bearer authentication middleware to accept tokens from my organization. I'm a Microsoft employee. I want to be able to use my Microsoft account to log in. I can do that by going to the Azure AD tenant and configuring this app, and you can do that manually through the portal. But we have some really nice tooling in Visual Studio that will handle that all for you. So I'm gonna go that route, and I'll show you what that looks like. So let me save this, and I'm gonna close this solution. I'm actually going to do, I'm just going to create a new project just to show you what this tooling looks like. So I'm going to again select that I want to create an ASPNET Core web application. I'm just going to leave the default name. That's fine. Sure. Yeah, save that. And again, I want to create a web API, but instead of leaving the default, no authentication option, I'm going to say I would like to use work and school accounts. And by default, it's going to select using a cloud authority, like using Azure Active Directory. And because I've already associated my Azure subscription with Visual Studio was kind enough to go and see, well, what are all the Azure AD tenants that you have access to? And I happen to have a few. For this demo, I know I want to use this one, danroth27dir.onmicrosoft.com. All right, great. So, OK. So let's use that as my authority. I click OK. And what Visual Studio is now doing for me is it's going and talking to that directory. It's setting up my app with that directory so that it's provisioned and ready to go so that my app can accept tokens from that authority. Now, that authority will actually be willing to issue tokens for my particular app. OK, so now I just have a simple Web API application. I should see a values controller in here. I do. But notice now I have that authorized attribute all set up for me. So it's secure. And then if I go look in the startup class, the Jot Bearer authentication middleware is already set up, and now it's actually already been pre-configured for me for that particular directory. And it's using configuration to get the actual coordinates of which authority and what my app ID is and all that stuff. All these configuration values, remember, they were coming out of JSON. So here's the app settings.json file that this app is using to manage all its configuration data. And there's all the important coordinates needed for this app to get to be able to validate tokens from Azure Active Directory for that particular organization. Great. OK, so now I've got a fully functioning, secure web API. It'd be great to now actually have a client that we can use to call this guy and actually try it out and use it. I'm going to spare you writing the client on the fly. I have one that's already pre-canned. So I'm going to open my to-dos application. So this is an app that still has a single web API. In this case, it's a to-dos controller instead of a values controller. But it's very similar in structure. You can get your to-dos. You can get individual to-dos. You can post a to-do. Pretty much the same stuff, except the model, instead of being value, is now a to-do. I did implement some data access in this application. It's using Entity Framework Core. Entity Framework Core is really cool because it has a nice provider model. It can read data from a variety of sources, whether that's SQL Server, SQL Azure, SQLite, and it even has a nice little in-memory provider that you can use for testing purposes and for demo purposes. So that's what I'm using here. I've set up EF Core in this app. We can see it. Where are you, EF Core? Right there. And I'm using the in-memory provider. If I go look at my startup class, you can see that I've set up not just the MVC services, but I've also set up a DB context, my to-dos context, as a service that should be available throughout my app, including available to my controllers. And I'm saying I want to use the in-memory provider for that to-dos context. If I go look at my to-dos controller, you'll see that its constructor now takes in that to-dos context. That's DI. Like it's just going to get injected in there when the controller is instantiated. So that's super nice. It makes this controller really easy to test. Like if I want to write unit tests for this controller, I could totally do that. All right, cool. So authorized. We've got the Jot Bearer authentication middleware all wired up. It should be provisioned with Azure AD. Let's check to make sure that's actually the case. If we go to, this is the actual directory. Let me refresh this and see if we can find. I should see that web application 1 that I had set up previously. And then I should have the to-dos test app in here as well. So let's see if it's there. All right, It's loading it up, trying to see what all the applications are for this particular Dan Roth 27 Durac tenant. All right, cool. And there's web application 1. So that's the one I just created a moment ago. And there's my to-dos test app that have already been registered with Azure AD. Perfect. And in here, if I go poking around, I can see all the configuration parameters for this app that have already been set up for me by Visual Studio. Okay. Now, what do I actually use? What do I actually use to get the token? So the nice thing about using Azure AD is they provide you authentication libraries that you can use for token acquisition and token management. It's called the Active Directory Authentication Library, and it's available for .NET, like if you're doing server-to-server calls, and it's also available in JavaScript. So that's a library that you can just grab and use. Now, for what I did for the client side of this app, this is going to have a SPA client, a browser-based client. I used that ADAL, Active Directory Authentication Library, for token acquisition. And the client app is also going to use Angular for its UI, just because that was simple. So here's ADAL. It's just a JavaScript file that I've dropped in here. It's available on NPM. It's available on Bower. And they also have a nice little integration into Angular where they'll make it available as an Angular service. If I go looking through this JavaScript code, here's also the actual to-do list service that this app is using to call the backend web API to get the to-dos, to post to-dos, and put to-dos. Okay, and then ADAL will automatically provide get the token from Azure AD and provide it for each of these requests so that you can be authenticated when actually calling the backend web API. Perfect. So that's what I want. By the way, if you want to try out this particular code yourself, you can. It's available on GitHub. If you go to GitHub Azure Samples and search for Angular, this first one, the Active Directory AngularJS single page app, that's basically the code I'm using for the client. The backend web API for this sample is, I think it's based off of ASPNET web API, but the one I'm using is based off of ASPNET Core, and we expect to have an ASPNET Core sample out soon. All right, cool. Well, let's run this app. So Control F5. Okay, so simple little UI. Says I'm not logged in yet. So let's go ahead and see if I can see my to-do list. And here it's asking me, you need to log in. And because I've set up that Azure AD security, I'm going to use my actual corporate credentials. So if you have a company and you have an app that really needs to be only for your organization, this is a great way to do it. And now I've got a nice little UI for managing a list of to-dos. Now, just so we can see the real web API requests occurring, I'm going to bring up the F12 debugging tools. And let's like, I don't know, I need to get a haircut. How about that? So there's a post request happening, and boom, 201 created, and then it went and got the to-dos that were updated and got them all and updated. So there's get a haircut. Like, what else do I need to do? I need to read a good book. Let's add that. All right, post pending. Perfect. Okay, great. So that's working. Now we can even look at these requests, and if we look at them, we'll see that in the request header, it's a little small, but down here at the bottom, you can see in the request header, there's that authorization header with the authentication type bearer, and there's the bearer token, the JOT token that's actually being sent to the server. And that's what that JOT bearer middleware is then pulling out, validating, make sure it's OK, and then allowing the request through. If I don't do it that way, like if I just make a request directly to the API, like API to-dos, like try to do a GET without having that token, then I get 401 unauthorized. You can see that down in the browser debugger tools. So this is a secure web API secured using your organizational accounts. It's pretty awesome. Okay, so that's security. So I hope you enjoyed learning about building web APIs with ASP.NET Core. Like I said, if you want to get started today, you can, absolutely. I suggest going to .NET, grabbing .NET Core, install Visual Studio, or if you're on a Mac, install Visual Studio Code, use the templates to build yourself a web API. You can find docs on how to go even deeper into all the various web API and web UI features in ASP.NET Core at docs.asp.net. And then you can join us at GitHub at github.com/ASP.NET. Thank you for joining, and yeah, I'll be around for answer questions on Twitter and on the Channel 9 page.